Hello everyone, welcome to this session. We want to continue with our discussion from the video that I sent and from the topic on decision making. We were left with a few techniques that we had not covered. We will still consider the example that was done where a farmer wished to decide on whether to plant wheat or beans or maize. And the outcomes of the conditions of the decisions was still high rainfall, moderate rainfall, and low rainfall. The probabilities were still as given. 30% for the high rainfall, then we had 50% chance of experiencing moderate rainfall, and 20% chance of experiencing low rainfall. I wish to move on from the techniques covered, and I want to first start with standard deviation. Now the standard deviation is calculated. We will not use the formula as you used in statistics, but we will use the formula for standard deviation as used in probability. And so in this case, the standard deviation will be given by the summation of the PIs, the probabilities, multiplied by the various deviations. So we have xi, the respective outcomes or payoffs, minus the mean, in this case, our expected monetary value, that squared. If you remember from statistics, you actually said that standard deviation is given by the square root of deviations xi minus x bar, that squared, divided by n. And what I have done is basically like if you expound this, then you will have the square root of x minus the x bar, which is our mean, that squared multiplied by 1 over n. Now in probability, 1 over n is the same as the probability of the respective outcomes, that we have 1 over n is equals to pi, and so we can replace this and rewrite as is equals to x minus x bar, that squared, multiplied by pi. So same thing, but then we apply this formula in statistics while we apply this formula in probability. So in probability, then we will not have x bar, and that is why I'm replacing with my question. I'm not using x bar, I'm actually using EMV, because essentially, even when you look at what you called mean in statistics, you actually said it is the summation of x divided by n. And so if I rewrite this, it can still be summation of x multiplied by 1 over n. And this would give me summation of x multiplied by respective probabilities. And if you do this, then this is what you called in probability expected values, EX. And in our management accounting, then if you look at this formula, then you'll actually find that this is what we call expected monetary value, where we multiplied all the payoffs in our table above by the respective probabilities in each case and summed up. So then if we go back to our formula, standard deviation is given by the square root of the summation of the probabilities multiplied by the deviation squared, Then we need to calculate the standard deviation of wheat, which will be given by, the standard deviation of the first scenario. We have 16,000 minus the expected monetary value of wheat is 5,000. So that squared multiplied by 0.3, which is the probability, plus 2,000 minus 5,000 squared multiplied by 0.5 plus negative 4,000 minus 5,000, that squared multiplied by 0.2, and this is still within the square root sign. Don't forget that. This was still a plus out of that. And so if you calculate this, then you can give me the answer. But then you can still do it together with the standard deviation of beans, which will be given as the square root of, with the beans we have 12,000 again and 7,000, and so when we come here the deviation is 12,000 minus 11,000, which is the expected monetary value, 11,000, and that gives us the deviation. Then we have to square it, multiply by the probability, plus the deviation under the second instance is 12,000 minus 11,000, that squared multiplied by 0.5 plus 7,000 minus 11,000, that squared multiplied by 0.2. And you can calculate that and still give me the answer. And then you do the same for maize. The standard deviation of maize will basically be the square root of 10,000 minus the deviation minus 10,000, the expected monetary value. You square that, you multiply by 0.3, and you do the same, plus the deviation will still be 0 squared multiplied by 0.5 plus 0 squared multiplied by 0.2. I'm talking of 0 because if you look at the data given, we have maize, the payoff or the profits for each scenario where we have high rainfall, it is still 10,000. Moderate rainfall is still 10,000, and low rainfall is still 10,000. And if you go back to what we did under expected monetary value, then we still have 10,000 as the expected monetary value for maize. And so if you compute the various profits minus the expected profits, then the deviation is 0. And that means you can adequately calculate these three and find an answer. Moving on from standard deviation, we are actually saying that we can use the next technique, which is also a measures of risk, and that is variance. And I'm sure from your statistics class, you can remember that variance was equals to standard deviation squared. And so this is quite easy because we have already computed the standard deviations, and so the only part you have to do is to actually square the answers you have gotten in the previous technique. And then we can move on to what we call coefficient of variance. And coefficient of variance, you'll actually find in statistics, you call it CV, is given by the standard deviation divided by the mean, but in this case we are talking of expected monetary value. These you multiply by 100 to make it a percentage. And so in each case you have actually computed the standard deviation and you have computed the expected monetary value. And so if you get this fraction, you multiply by 100% to get the coefficient of variance. What you need to note is that standard deviation, variance, and coefficient of variance are all measures of risk. And I think I will discuss the last technique with you before I move to something different. And in the techniques, I want to look at decision tree. Now, the decision tree is what you could have called in your statistics class probability tree. In secondary school, we still referred to it in mathematics as probability tree. But then again, for this scenario, because we are talking of an application unit, we are using it to make decisions. And so in management accounting, we are referring it as decision tree. Now, what you need to capture is that you need to draw the tree itself, and you can start with a branch. Then in this case, we had 3 alternatives, and you can draw the 3 alternatives. And with the 3 alternatives, we are talking of wheat, we are talking of beans, and we are talking of maize, and that is okay. In each of these scenario, we have sub-branches, because we are talking we could experience high rainfall, we could experience moderate rainfall, and we could still experience low rainfall. And even with beans, we still have 3 outcomes. We have high rainfall, we have moderate rainfall, and we have low rainfall. And in this maize scenario, we still have high rainfall can be experienced, moderate rainfall can be experienced, and we can still experience low rainfall when we plant maize. Now, moving on, you need to capture the data given. When we plant wheat and we have high rainfall, you could label this as high H to mean high rainfall, M to mean moderate, and L to mean low. And so we have H, M, and L. Then we have H, M, and L. And so in this case, we are saying that the probability here is 0.5, the probability here is 0.3, and the probability in this scenario is 0.2. Then we have 0.5, 0.3, and 0.2. 0.5 for high rainfall, 0.3 for moderate, and 0.2 for low. And if that is the case, then we can put the payoffs, and we can have this was 16,000. This was allow me to refer to our question. This was 2,000 profit, and this was a loss of 4,000. And so we can move to the next one. The next one, we had 12,000. If we planted beans and we had high rainfall, if we planted beans and we had moderate, we would still earn 12,000. And if we planted beans and we had low rainfall, we would have earned 7,000. And for maize, I think it is good to note that for all scenarios, we had 10,000 in each case. And so you just put 10,000 for each scenario. Now when it comes to the decision trees, we need to move back